You're listening to STEMxm, where women in science, technology, engineering and mathematics share their stories of success, overcoming barriers, and breaking the glass ceiling. And now, your host, Mel the Engineer.
Hello and welcome to STEMxm. I'm so glad you joined us for this episode because we're about to embark on something really fun. There's been a bit of a break since I released an episode, and it's because I decided I wanted to develop a couple of series. So this first series will be focused on water and wastewater profession, and that kicks off today. I'm doing my best to get some other women scheduled who specialize in drinking water treatment, stormwater, and the next one I release, I'm expecting to have a woman on who specializes in municipal water and wastewater master planning. So here on episode 17, we're going to be speaking with an environmental engineer that has expertise in municipal wastewater treatment, but even more specifically, she's an expert in the operations side of treatment, so you'll hear more about that. Her name is Stacy Passaro. Stacy holds a BS in Civil and Environmental Engineering from Clarkson University and a Master of Engineering in Environmental Engineering from Johns Hopkins. Stacy has extensive wastewater treatment process design experience, and she now owns and runs her own consulting company. So take a listen to our conversation, and I'll be back at the end to discuss show notes. Stacy, welcome to STEMxm. Thank you so much for joining us.
I'm glad to be here.
So I want to start off chatting a little bit about your background. Can you tell us where you grew up?
I grew up in central New York, up just on the south side of Lake Ontario.
And when you were young, did you have an early draw to subjects like science and math, or is there something that happened later on that kind of led you down that path?
I enjoyed most subjects in school, but it was really my freshman year of high school I took earth science, and I just loved that class. I loved the teacher, and we had a really small class. There were like 5 or 6 kids in that class, and I just monopolized all of the teacher's time. We just kind of chatted about all sorts of stuff, and I guess it was kind of at that point that I really realized that that was something that spoke to me.
Was there any specific thing that happened in that class, or a topic that came up that really struck a chord with you?
I don't really remember there being anything specifically. I really didn't. I mean, I work in water now, and I would say that it was kind of a winding path for me to get, from that earth science class that I was just really enjoyed. It didn't even seem like a class. It was just kind of something I was just interested in. I wanted to know more about. And from there, I ended up in engineering, and it still took a circuitous path before I found my home in water.
Okay, and were either of your parents engineers, or do you feel at all like their vocations or their interaction with you impacted your interest in engineering or the ultimate career path that you took?
Yes, I do. I mean, they weren't engineers. My mother was my high school math teacher. So I guess from an early age, I saw women in math and science, through my mom. And actually, I had her. She taught me in high school. I had her for math for 5 years, and she was the best calculus teacher I ever had. So I wished I could have taken her to college with me, because she would have made college much easier. So I definitely got the math background from my mother's side. My father did not go to college. He went to work at Xerox, and he ended up doing an internship when I was, 10 or 12, in kind of a an engineering related background, and he ended up going into maintenance. And he took a bunch of classes at the local community college. And it's kind of funny because I do quite a bit of teaching training now. And I also work a lot with our utilities on their maintenance programs, which kind of ties back to the work that my father did.
Yeah, absolutely. That's really interesting. So I was going to ask how it was to have your mom as a teacher in high school. Was that weird at all?
It was funny because I went to a small high school, and she said before class started the first year, I was actually in 8th grade, and I went over and I took a freshman math class. So I was terrified anyway going into the high school, and there were like 4 or 5 of us that walked across the street from the middle school and went. And my mother said, I can't show you any preferential treatment. You have to call me Mrs. Marsteiner in class, and you have to act just like everybody else. And once I got there, I realized most of the other kids called her mom. They could call her mom, but I couldn't. So I called her Mrs. Marsteiner for 5 years. But she was a good teacher. We were all scared of her, so she had a teacher voice, and we still tease her about that to this day. But whenever we'd get in trouble, she'd use the teacher voice, and she would scare all the high school students.
Oh, that's hysterical. Okay, so walk us through what happened next then.
Well, I did actually go into engineering. Okay. I kind of narrowed it down. I knew I wanted to do something in math and science. And when I started doing some research my senior year, I realized that engineering had a ton of different areas you could go into. And I talked to my parents about it, and they suggested that I check out a program that was done through the University of Notre Dame. They had a Women and Minorities in Engineering program, and I went out there for 3 or 4 weeks the summer between my junior and senior year of high school. And it was kind of neat because they gave you an intro to all the different branches of engineering. And you'd spend like a day doing chemical engineering and a day doing electrical engineering. And they would kind of run through different classes that you would take. And then they would give you a little project that would be something sort of kind of tied to what you might do someday in a career in that field. And then they took us on some field trips. So that was a very, very helpful class for me program for me, because I really didn't know what engineers did every day. I couldn't really relate to it because I didn't know any engineers. So taking that really helped, and it helped too, I think, to be immersed, in the group that I was with, and obviously there were a bunch of women in the group. So it was met some really nice people from all over the country through that.
Yeah, that sounds like a fantastic program. Really fortunate that your parents found that.
In the day before, I guess, back then, I'm not even sure how they found it. It's not like you could just Google it. So,
right.
Yeah, so it was kind of neat that they found that. It was very helpful.
Yeah, absolutely. So when you went in, you went directly for civil, and you were like, I know this is it. This is what I want.
Yeah. I liked, that was the module that we did at the summer program that I liked the most. But I wasn't sure, if I wanted to get into bridges or roads or water or, I just knew generally that seemed to be the area that interested me the most. So at the university I went to for undergrad, they had a combined program that was civil environmental. So that was kind of how that all tied together.
When you went through your bachelor's degree, what were the proportions like roughly at that time, men to women?
In my class, I believe it was 6-1.
Yep. Okay.
And I don't know, somebody told me that that's still fairly consistent today. Is that true?
Yeah, that's true. I think overall for all of the engineering disciplines combined, it's probably close to that. I know that I was particularly curious about it, and I counted in each of my own classes that I took, and it was never more than 20% women, so 1 in 5 at the most.
Yeah.
So that was my experience. But yeah, I don't think it's improved a whole lot over the last couple of decades, and I think we've even seen in recent years a decrease in women going into the engineering around computer sciences.
Wow.
Yeah.
That's too bad.
Yeah, it is. So we're working to fix that a little bit. But I won't get off too far off topic on that right now. Okay, so you earned your bachelor's degree. Did you do any internships while you were in school? And if you did, how did you find those?
In undergrad?
Yeah.
Yes, I did. And that is one thing that I always highly recommend to anybody who is studying right now. If there's any way at all that you can get involved in a co-op program or an internship program, I think the experience you get is just incredibly valuable. So through Clarkson, I went to Clarkson University, which is up on the Canadian border, above the Adirondack Park in New York. And small school, almost all, well, back then it was almost all engineering. And they had a program with several companies, that they developed relationships with over the years. And they would come up and interview and then offer internships for different periods of time. So I went ahead and interviewed and got a couple of job offers and took a position with a firm that was in Syracuse, just outside of Syracuse, New York, which wasn't that far away from school. And I started my junior year. I took classes through the summer so that I guess it was the summer between my sophomore and junior year, and then junior year in the spring term, so January, I went to work, and I got to work all the way through August and then come back to school for my senior year.
From a technical perspective, what did you get to focus on in those internships?
They tried. The firm worked in a couple of different areas. So they had said, since you'll be here for 8 months or so, we will try to work you through our different groups. So they had a wastewater group. They had a drinking water group. They had a solid waste group. They had a survey department. So they tried to move us around. And it just, I guess, by luck of the draw, I was assigned to the wastewater group when I first got there. And I worked primarily in that group during my internship. They did put me in the drinking water group for a while. And they did offer to put me over on the landfill side for a little bit, but I really wasn't that interested. So I did a little bit of work with them, but was primarily focused in the wastewater group while I was there.
Okay, and so what would come across your desk that you would get to help with? Would it be design, or would it be something else?
I was assigned to a construction project that was in Connecticut. Ironically, I never got to see that construction project at all. But I worked in the office in Cazenovia, which is right near Syracuse, and basically processed all their shop drawings and submittals that came in for the project.
Okay, so for somebody who's not familiar, like a listener that's not familiar with the whole process, I want to try to describe this a little bit for them. So So somebody has already completed the design, right? And it's gone to a constructor. And so throughout the process of construction, they have to submit these things that you're talking about, and those have to be reviewed.
Correct.
So can you describe those a little bit and why that review is important?
So the contractor has to bid on the project, and they read through the contract specifications and the contract drawings, and they put together their bid, which is basically costs for purchasing all of the equipment, the cost for purchasing concrete and rebar and everything they need to build the tanks and do the site work and do the civil work, which would be the piping and the electrical and all that good stuff. And they put in their bid, and oftentimes, and we've had some changes in that we have other delivery mechanisms, but back then primarily we were doing all low bid. So the contractor puts in the bids, and maybe they get bids from 6 or 7 contractors, and they award to the lowest cost. So then that contractor gets the work and then goes out and asks their suppliers to put together the shop drawings, which document exactly what kinds of equipment they want to use, what kind of material they want to use, and all that comes into the engineer. And the engineer reviews it to make sure that what they designed is really what they're being offered in these packages that are being submitted. And if there is any substitutes or any, changes that come up in the equipment packages, then that all has to be coordinated during construction.
Right. Okay. So an example of that might be a substitution would be, if you, the engineer, have specified 3 different brands for a big pump, and the contractor comes back and says, well, I'd really rather use this brand. Then they have to provide documentation to support that it is as good as what has been specified in that package.
Correct.
Okay. Awesome. Thank you so much for explaining that. Okay. So jumping forward from there. So you get your bachelor's degree, and then you take your first job. Did that come through your internship, or did you find it another way?
It did come through my internship. The company that I worked for came back to school and was hiring a couple of, ended up hiring 3 full-time engineers out of our class. And so they offered me a position back with them.
Very nice. And then you decided to go back for a master's degree. What made you decide to do that?
I started working in New York, and shortly after I started as a full-time engineer, one of the engineers that I had been working with as an intern had left to come down to Maryland to open a new office for the same company. So he called me and he said, we're looking for some other young engineers. We need cheap people, low-cost labor to help us get this new office started. So would you be interested in coming down and working long hours for low pay?
Did he actually say it like that?
He kind of half jokingly, but half seriously did say it. And I was, I guess just maybe my personality, I was a little frustrated. I had done a lot of work as an intern, and I kind of had very few restrictions on what they let me do. And when I went back as a full-time engineer, it was it was not a big office, but a little bit bigger, a couple, 125 employees. And they had very kind of stringent rules for what you could do as an engineer 1. And I was getting very frustrated with that because it was stuff I had already done for 8 months before I was an engineer, before I graduated. Mm-hmm. So I didn't like the rules and the restrictions. So the thought of going to a new office that was kind of like you just jumped in and did whatever came your way because you had to, because there was only 2 or 3, engineers there. That kind of appealed to me. So that was why I moved to Maryland. And we worked for, I guess, a couple years, maybe 2 years. And the same guy that called me in New York and asked me to go down and work in the other office, he decided he was ready to do his master's degree, and he was going to talk the rest of us young engineers into going with him. So we all signed up and went to Johns Hopkins and did our master's degree in the evening.
And what did you specialize in when you did that?
I did a Master's of Engineering and specialized in wastewater.
Okay, so talk to us more about wastewater in general. What is it that you like about it, and what drew you to that specific area early on?
Wastewater is actually very complex. There's many different aspects of it that when you get into the biological treatment, of course, there's chemical treatment, there's physical treatment, and the treatment facilities themselves are very, very complex. And when I moved from New York down to Maryland, at that time, the pollution in the Chesapeake Bay was causing lots of issues, and they were really ratcheting up the nutrient regulations here. So it was kind of an exciting time because there were a whole bunch of pilot studies going on, and just looking for ways that we could remove the nutrients from the water before we discharged it to the streams and rivers, which ultimately went to the bay. And it was pretty, new, and it was just kind of a fun time to be involved in the wastewater industry.
Absolutely. Can you describe for our listeners what you mean by a pilot study?
So there were lots of researchers who were finding different interesting things in labs in very little tanks that they were, we call it bench scale, where it's actually very small tanks that sit on a bench in a laboratory, and they were running the little bench scale projects different ways and finding that they were getting good nutrient removal. But then we had to kind of scale them up and figure out how to apply them at a full-size wastewater treatment plant that might treat millions of gallons of flow from a city. And so, before we spent a lot of money retrofitting a whole plant permanently for some of these technologies, we wanted to try it on a treatment train. So lots of the plants are set up where you can kind of isolate one, like a quarter of the flow would go through a set of tanks. So we could isolate that one train and take the quarter of the flow that the whole plant was treating, and we could kind of change those tanks. And we could use biofilms, and we could use some different, technologies there, and kind of do full-size pilot tests on that train. And then, of course, collect a lot of data so that we could figure out if we were going to really be able to scale some of these technologies up and use them for the whole treatment plant.
You're listening to the STEMxm podcast. I'm your host, Mel the Engineer, and today we're speaking with environmental engineer Stacy Passaro. She's describing some of the issues that come up in surface water when there's too much nutrient pollution. So basically there was pollution that was instigating a lot of this research that you just described. And so the problems in the Chesapeake Bay, what were they caused by?
They were caused by a whole lot of people that were moving to the area. The DC, Baltimore areas were, growing. and sprawling, spreading out and affecting developments were popping up all over. So the land use all around the bay in this area was changing rapidly. There's also a lot of areas where they had smaller cottages and smaller homes all around the water that were all on septic tanks, and some of those septic tanks were also aging and starting to fail at the same time. So there was kind of different levels and different sources of the pollution, but everything from the wastewater, just the increase in the volumes of wastewater that were being generated by more people living in the area. More land was being disturbed to be developed, so that was causing a lot of sediment issues. And then we had septic tanks that were failing. So all of these things on top of each other were just causing all sorts of issues in the Chesapeake region that we really needed to get our arms around.
Okay. You're really the first person that I've had on the podcast that does any type of wastewater treatment. So I want to pause for a second and make sure we explain a couple of things before we go forward. And so I am going to have a couple episodes after yours where I talk to people about other aspects of water and wastewater treatment, but I just want to cover some of the basics. So you mentioned nutrients, and maybe for somebody who's never thought about or read about clean water or wastewater treatment, they might not know what we're talking about, right? So do you want to explain, when we talk about nutrients, it could sound like a good thing, right? Like, I need nutrients and you need nutrients and plants need nutrients, but when it gets in the water, it's a bad thing. Could you talk about that? Sure.
I'll try to cover a little bit. So there's two main nutrients that we really focus on. They are nitrogen and phosphorus, and there are different sources of them that get into our wastewater. And nitrogen, for instance, the ammonia is a form of nitrogen, and urine is a primary source for ammonia that's in wastewater. Phosphorus has years ago, almost all of the laundry detergents were phosphate based. And since then, we've cut back on that. We've tried to reduce the amounts of phosphorus that we put into the wastewater through sources like that. But there's still lots of different sources where phosphorus and phosphates get into the wastewater as well. And they are nutrients. They do help plants to grow, so they're not always a bad thing. We use them. Farmers use them, of course, on the fields. Apply fertilizer on fields to help the plants grow. What happens, however, when we get the nitrogen and phosphorus in our wastewater, is that it causes algal blooms in the water. So usually it's not an issue in the rivers because the rivers and the streams move quickly enough. But when you get to the bigger body of water that the streams and rivers dump into, all the sediment that contains the nutrients tends to settle and sit right there, and it causes the green murky water. Here in the bay, it's caused all sorts of issues where the murkiness of the water blocked the sunlight from getting to the bottom of the bay, which caused the bay grasses to die. And the several different types of aquatic life use the bay grass as either food sources or places to hide. The baby, whatever the baby crabs are called, the little crabs and the small fish and everything hide in the grass when they're first born. And because we had upset the kind of balance in the bay and the grasses were in decline, then they were all being eaten. And of course, then our populations were really being affected. So there were lots and lots of issues that the nutrients ended up causing in the bay, or still cause today, unfortunately, in the bay.
Thank you for explaining that. That was a good explanation. So it sounds like the sources that you mentioned that nutrients come from in this fashion, like polluting a big water body like this, it would be the wastewater effluent itself if it's not treated to say a really high standard, or runoff that has fertilizer in it. And then also you mentioned failing septic tanks.
Correct.
Yeah, so that's a lot of different places.
Yeah. Well, in the stormwater in the cities, so the more concrete, the more rooftop, the more impermeable or impervious surfaces that we have in the cities, then the more dust and dirt and everything gets washed off those surfaces during rainstorms, gets washed into the river, into the creeks, into the streams. So stormwater is also a big source. And then, the farmers' fields are also, depending on how fertilizers are applied, that can have a huge impact on the local stream and river quality as well.
Yeah, you reminded me when you were talking about the stormwater just then. I read a couple of studies that actually looked at how much of an impact there was in neighborhoods where people didn't pick up dog poop, and that got washed into the stormwater and everything. And it's actually, in terms of nutrients, a pretty big problem. So PSA to pick up your dog's duty.
Exactly.
Yeah. Okay.
Little things that all add up.
Yeah, totally. Okay, so thank you for explaining that piece of it to us. So let's move forward in your path. So you left that first company at some point. What did you decide to do after that?
I was working as a consultant, and I was traveling quite a bit, which I had wanted to do when I was younger, and had asked to do, and enjoyed it for a while. But there comes a point in your life where suddenly being on the road a lot can be a detriment, and I was kind of feeling a little bit like over being on the road a lot. And I was married by that point. My husband and I were talking about having kids, and I just wanted kind of a change in my work life that would be more amenable to a family. So I decided to make a change and to get out of consulting for a while and work for a nonprofit, so that I would have the opportunity to kind of have a more controlled work schedule, travel schedule, and be home and have kids.
Very nice. So what nonprofit did you go to, and what did you do there?
So I went to work for the Water Environment Federation, and I was at the time they called it their technical education department. And I basically got to work directly with the technical committees in the Federation that oversee all different areas. I think at one time I had 7 or 8 different technical committees that I was working with. And each committee, there's a collection systems committee, there's a plant operations and maintenance committee, there's a small communities decentralized treatment committee. So they all had very specific focuses, and I got to work directly with them. So they were all WEF members who volunteer their time and donate their expertise to different projects that are going on within the Federation. And I got to meet and work with hundreds of different WEF members from all over, definitely all over the U.S. Actually, from all over the world, truthfully. So that was a great opportunity there.
Right. So for our listeners, WEF, or Water Environment Federation, they have a pretty big focus on municipal wastewater treatment, and so the committees that you just described, they're each kind of a different aspect of municipal wastewater treatment. So you mentioned collections, so that is almost what it sounds like. It's actually the system that's collecting all the, poopy water around town and conveying it to where it needs to go. And then I can't remember the other ones that you mentioned, but maybe you could describe a couple of those.
Sure. So the plant operations and maintenance, they're, we in consulting, I was working primarily in design. So we would come in, when there was an issue, when a utility decided that they needed either an expansion, their plant was getting to be too small for the flows that were coming in. They would hire a consultant to come in and build new tanks or expand the capacity of the plant. Or when there was an upgrade needed for a new regulation, and say they were just adding new or more stringent nutrient levels, then consultants would be hired to come in and do the design work to upgrade the plant. In the plant ops operations and maintenance committee, it really focuses on the other piece of that. So after the consultants do their work and after the contractors are in and build the new facility, at the end of the day, everything gets turned over to the operators and the maintenance folks that work for the utility. And then it's their baby, it's their facility to run, and to make sure they meet their permit discharge limits. So that committee focuses just on the operational aspects and the maintenance, kind of the long-term life of the facility. We had other committees like the safety committee. There's a lab practices committee. So in bigger plants, there is they'll have a laboratory right on site where they take all their own samples, and then they test it right there, and then they submit the results to the state to show that they're meeting their NPDES permit. So there's a lab practices committee. There's a utility management committee. So that's just kind of looking at the higher level of, how to set your budgets up and what the best practices are for renewing assets over time. I'm trying to think of some of the other committees. I mentioned the small communities and the decentralized treatment, which are kind of just a different take on how we do the treatment, where we locate the facilities and how big they are.
Okay, you mentioned a couple things I wanted to highlight. So the first thing is, so operators and the maintenance people that are working for the utility at the municipality, they're really unsung heroes that I feel like, your everyday citizen, they don't get to see that. They don't really know what that's about. But, these people, typically, if you're in a city of any decent size, there are these operators working round the clock at a water treatment plant or a wastewater treatment plant to keep everything running. So that's a really interesting career path in and of itself.
Yes.
And then you also mentioned permits, discharge permits, and NPDES permits. I wonder if you might talk about that for a moment. I feel like in this time right now of a very unusual political climate, you hear a lot about deregulating. So I wonder if you might shed some light for us on the importance of some regulations with respect to wastewater.
Yeah. So yes, it's a very timely discussion. EPA, the Environmental Protection Agency, is there's several levels of EPA. There's a federal level, which is headquartered in DC, and they oversee rules that apply to everybody, to every state. And then at the next level down, EPA has regions, and there's region 1, 2, 3. Like Maryland is in region 3. And so usually the regions are collections of maybe 3 or 4 states together, depending on how things are located and positioned. But they're a region of the country. I think I don't know them off the top of my head. It's terrible. Region 1, I think, is New England. But anyway, so they're grouped together at the regional level. They oversee some of the issues that apply kind of, it's not just a state, it goes beyond a state, but they're in not a huge area. They're just a region of the country. And then there's state level EPA offices as well that operate under the region. So we have these different kind of layers of regulation. And, oftentimes, like for the Chesapeake Bay, and that's a good example because the Chesapeake Bay watershed is huge. Rain that falls up in Cooperstown, New York, which is where the Baseball Hall of Fame is, that water will travel through creeks and rivers all the way down through Pennsylvania and then ends up down in the bay. So if we were to just look at environmental issues on a state level, we would never, ever begin to get our arms around an issue like pollution in the bay because it drains this huge, huge portion of the East Coast, all drains there. So we have this network of kind of regulations that is supposed to help us all kind of stay on the same page and keep us moving in the right direction. And so the NPDES permits anytime you discharge into a water body, you have to have a discharge, an outfall permit, basically for that discharge. And the regulators will look at what that body of water is used for, if it's used just for recreation, if it's used as a drinking water source, and then they'll look at other sources of pollution that are also going into that water body, and then they will set some limits of how much pollution you can add at your outfall. And that ends up being your NPDES permit, which is the National Pollution Discharge Elimination System. I might have missed a word there. But basically, it's trying to look at how all of these cumulative effects of all these different discharges work together and how we can maintain or improve the water quality of a receiving stream or a downstream, larger water body like the Chesapeake Bay by having all these permits work together.
That was a really good explanation. So I think what is happening now too, as we become more populated and as industry grows and there's more demand for water from different types of industrial manufacturing and whatnot, I feel like what we're beginning to realize is that no water source should be discounted as something that, we can pollute that one because we have this other source over here. It's just becoming too scarce.
Right.
Yeah. So maybe on another episode, I should dive into the water energy nexus. And,
yes. Yeah.
Some of those.
That's a very good topic.
Yeah.
You can talk for a long time on that.
Yeah. Okay. So I want to get back to you before we run out of time. So you're an entrepreneur today. So tell us about what happened that made you decide to start your own business and how did that come about? Because you have some specialization, I think, on the operations side. So can you tell us about how you developed that and Yeah, just tell us about your business.
Sure. So I worked at WEF for I think 8 or 9 years, and developed a wonderful network of professionals that do all sorts of different things in our industry, and just felt myself being drawn towards back to the utilities, back to the facilities themselves. And I worked in consulting. In the beginning, I worked on the design end, but I was always kind of, I don't know, drawn towards the operations end and the maintenance end, because as you mentioned, and I appreciate your little intro there, they really are kind of the unsung heroes. And at the end of the day, everybody goes, everybody leaves, and the operators are kind of left with this collection of pumps and pipes and instrumentation, and they have to make it all work together and kind of produce the end product, which is our clean water, and meet the permit. And it always seems like the things that go wrong tend to happen at 2 a.m. in the morning during a storm or Christmas Eve. And they're always, when something happens and they get called out on an emergency, it always seems to be like those times when the rest of us are kind of home tucked in bed, or, we're with our families celebrating a holiday, and they're on call and they're out kind of dealing with things. So I just kind of felt myself being drawn towards trying to help, work with them, do consulting work, but work with them on the day-to-day operational issues, ways to manage things differently, where you have kind of better reliability, redundancy, not so much redundancy, but you have the flexibility in the way you can run things, so that if you lose a pump, that you have other options. That if you need to do maintenance, you have ways to work around that piece of equipment while it's down for maintenance, that you schedule your maintenance differently so that it's less disruptive to the overall operation of the facility. So I just really felt like that was an area where I could help. And it was kind of an area where there's not a lot of people kind of focused on that. So I felt like there was kind of a niche there that I could add value to. And so I went back to work, and I really wanted to be back out in the field. I obviously, being an engineer, I have plenty of office time, and that's fine. But in a perfect world, I love to be out at the utilities, a day or two a week, because I think it really helps you kind of stay in touch with what's going on, and being able to relate to what they need to deal with every day, and trying to find ways to help them deal with that stuff. So I try to get out in the field and spend some time at the facilities, and then really kind of work with them to tackle some of the bigger O&M issues that pop up.
Could you give us a specific example of maybe where you've helped with the design of something and you implemented something really specific to make it more operator friendly?
Yeah, there's lots of times during design, you become kind of focused on your direct client, of course, is the management of the utility. So they're looking at how much they're going to have to pay for this new project that they're putting together. So we start to focus on kind of minimizing pipe lengths, and trying to save a few dollars here and there with the way we arrange stuff. And the problem is, if you don't have somebody who's very well versed in the operation of the equipment involved at that stage of the design, sometimes we can make things inaccessible, so that if you have to come in, you have a pump in the middle of a skid that has all this piping and valves and instrumentation around it, and you're trying to save this room, and you're trying to make your building footprint smaller so that it's less expensive, and you're trying to be good stewards of, the ratepayers' money. You're trying to keep your construction project cost low. We sometimes design things and build things that you can't maintain long term. So when that pump, which will wear out sooner or later, and you're going to have to access and you're going to have to change parts on, they can't get to it because the piping's so tight around it that they can't actually pull it apart to get to the pump. So it's those kind of details that I try to help with, and try to keep the end goal of having a facility that we can operate and maintain properly, making sure that those needs are kind of kept in the forefront during the design and during the construction.
Right. And I just want to point out that this is a big deal, because part of what you have to do that I was reading between the lines just there, right, is that you have to be able to demonstrate that spending more money now will kind of be less money in the long run, because it means you won't have to redo this whole system later on.
Exactly.
When it could.
Exactly.
Yeah.
And it's hard when you're saying, well, it's going to cost X dollars right now, but trying to document and show how that's going to save in your everyday O&M costs down the road can be a little bit of a challenge, because we're all very focused on the check that we have to cut today, right? So you have to kind of you have to build a relationship, and you have to have people be ready to look at the bigger picture and think down the road, and be bought into making that plant be O&M friendly.
Right. And again, you've highlighted some things, and you use your own strengths in communication and your ability to build these relationships and garner trust with multiple different types of people to create a better outcome for everybody who is involved. So I just think it's interesting that, thinking about relationships and negotiation and communication, those are not things that get highlighted in engineering school, but it's not even something we necessarily associate with engineers, but we actually need to foster those skills to be able to come up with these creative solutions and to work together with these people, because the engineers are not always as cognizant of, the operator's needs like you described. So I just think it's so cool, that you've focused on this.
Well, I think, at the end of the day, and there was even for a stretch of time, there was actually a kind of a push for taking people or minimizing people's involvement in the day-to-day operations. And when instrumentation and everything, it gets more and more sophisticated. And the thought was kind of like, well, can we engineer the operator out of it? How cool would it be to be able to say, well, this plant's completely self-sufficient and there's no chance for any human error here, because the computer's going to run the whole plant. And people, designers kind of started to go down that path a little bit of, wow, we could do this. This is cool. And if everything works exactly the way it's, supposed to, and there's never a hiccup, and there's never a problem, and there's never anything unforeseen that comes into the plant, the influent, and there's never an electrical issue, and the instrumentation never goes down, and no equipment ever fails. Well, maybe you could do that. So maybe for a couple of hours at a time, you can achieve that nirvana where the computer can run the plant. But as soon as anything changes, as soon as anything happens, you have to have a live person there, and you have to have a well-trained person there who can read all the different variables that are going on and figure out how to quickly fix it so that they minimize the damage that's done and they minimize the amount of pollution that goes into the environment. So I think we've corrected from that kind of whatever pipe dream that we had for a while, that we could actually remove the human element from our plants. I think most people would agree today that instrumentation and complex control systems are wonderful, and they help us do a better job. But at the end of the day, we still need very well trained people running the plant. And, we need to have people that can communicate with each other, cooperate, and work together to really get the job done. Because there's a team that, of people with all different skill sets and different expertise that really need to be involved in running a plant that's as complex as many of our plants are today. And I think there's a kind of a renewed interest and a renewed understanding of the value of people in the process and having us all work together properly.
Yep, absolutely. Okay, I've got two more questions for you today. So my last question is there anything that you want to get out there in terms of a message about wastewater treatment or operators or anything on this subject that maybe your everyday person doesn't know? So somebody who's not in the world of water and wastewater treatment, is there anything that you want them to know?
Well, I guess water is truly the basis of life, and we have taken water for granted for years. And I think when I first started working in wastewater, I was kind of terrified of it. I really didn't know what wastewater was. I had grown up in the country on a septic system. I really wasn't even, familiar with collection systems or, cities that would have bigger plants. And I think I totally did not understand the scope and the breadth and the importance of water in our day-to-day lives. And so I guess that's one thing just from my own background. As I've gotten to understand the field, and I love working in water, and water is just something that is absolutely positively necessary for every single living thing on earth. So there can't be enough emphasis on the importance of us protecting it and working together to keep our water safe and keep it clean. So that's just a bit of a plug for water in general. And our teams in wastewater, once you actually get involved, there are very many different groups that all work together, and we still need to find better ways to communicate, better ways to share ideas, better ways we can improve the overall process, and we can improve the overall outcome if we can knock down some of the silos and be open to sharing ideas earlier in designs and earlier in construction processes. So, people get things done, and people being willing to be open-minded and listen and work together is just a critical piece of every project we do.
That was a great answer. Okay, so my last question is, for the young women that are listening, do you have any advice specific to them if they're interested in going into perhaps engineering in general or civil and environmental engineering specifically?
I think we need more people. There's so much work to do, and it's a terrific job because for me, it's very fulfilling because it's something that's so much bigger than any one person or anyone. It's something that helps everybody at the end of the day. So it's a very fulfilling career. And, I think maybe you did touch on it a little bit when you were talking about communication. Women in general, I think, tend to put more emphasis on relationships. And I think that's something in engineering that we need to do more of. So it's actually kind of an innate skill, something that we all practice from the time we're younger that is needed in engineering. So I think it's actually kind of an extra level that women bring to a project that really helps the overall success of the project. Engineering's been fantastic. Not to say that there's not still people that you will bump into along the way. Every woman who's worked in a male-dominated field has been told that they don't belong, or that they don't have what it takes, and that's just absolutely not true. I think that there's fantastic opportunities, and I think that you have to go into it maybe being ready to not let naysayers ever tell you that what you can and can't do. We all have to kind of make our own futures, and looking at things, doing your research, understanding what you're getting into, and then following through on it and believing in yourself is something that's critical for any career. But there's always going to be people along the way that tell you you can't do it, and that's not true. You just have to believe in yourself and push through.
Absolutely. Stacy, thank you so much for coming on to STEMxm and telling us about your experiences and some of those details in wastewater treatment. It's been a real pleasure to speak with you.
It was very nice to talk to you. I'm glad that we got a chance to talk through things, and I think it's terrific what you're doing with this series, and I would love to support it in any way I can.
Awesome. Thank you so much, Stacy.
Okay. Thank you, Mel.
Stacy showed us a great example of how you can be successful in engineering in multiple different ways. She went from consulting to a nonprofit and then back into consulting as an entrepreneur. I'm so glad we got to have her on the show. I've got show notes ready for you in the usual place. Simply go to STEMxm.com/episode 17. That's STEMxm.com/episode and then the number 17. Like I mentioned at the beginning, I'm working on a water and wastewater series, so I hope you'll join us for the next episode, which I expect will be with the Municipal Master Planning specialist. Thank you again for joining us. It would really mean a lot to me if you would consider sharing this episode or the podcast as a whole with someone around you that might benefit. It could be a student or a teacher, and you could share it on social media or by telling someone about it. However you do it, it helps the show out. So thank you again, and I'm looking forward to chatting with you in the next episode. Thanks, everyone.
This has been an episode of the STEMxm podcast. Thank you for listening. We would really love if you could pop over to iTunes and give us an honest, positive rating. It helps more listeners find us to learn about STEM careers. Thanks again, cheers, and we'll catch you on the next episode.